All right, here in the third video of 1.2, we're talking about infinite limits as x approaches some constant value a. And in this video, we're only going to have one new vocabulary term. It's vertical asymptote, runs opposed to horizontal asymptotes like in the first video, and no theorems to worry about this time around. So let's get into infinite limits as x approaches some constant value a. If the values of a function f of x outgrow all positive bounds as x approaches a finite number a, we say that the limit as x approaches a of f of x is infinity. So outgrow all positive bounds. So another way to say outgrow all positive bounds is increases without bound. I've heard that one before as well. So it's increasing without bound. And if the values of f become large and negative, exceeding all negative bounds as x approaches a, we say that the limit as x approaches a of f of x is negative infinity. And again, that would be decreasing without bound. So let's take a look at the graph of f of x equals 1 over x, and we want to think about what's going on as x approaches 0 from the right and as x approaches 0 from the left. So over to Desmos, here's 1 over x. As we approach 0 from the right, the graph of f of x is increasing, and it's increasing how? Without bound. He just keeps growing and growing and growing, and this is never going to level off. In fact, it's going to grow even faster the closer x goes to 0. From the left, same story. This graph is decreasing without bound. It's getting smaller and smaller and smaller at increasing rates. So what we're going to do is come back to the notes. We're going to say as x goes to 0 from the right, the limit of 1 over x is infinity. And the limit as x goes to 0 from the left is negative infinity. One note here, remember that infinity is not a number, and infinity does not imply that the limit exists. In fact, what infinity is telling us is how the limit does not exist. So, even though we put the equal sign here, what we're actually saying then is that this limit does not exist, but this infinity is more specific. It's how. It doesn't exist because it's increasing without bound. Okay, the definition then. The line x equals a is a vertical asymptote of the graph of a function y equals f of x if either the limit as x goes to a from the right of f of x is infinity or negative infinity, or the limit as x goes to a from the left of f of x is infinity or negative infinity. So in that graph of 1 over x, we would look at the line x equals 0 as a vertical asymptote, because as we approach 0 from the right, here we have infinity. As we approach 0 from the left, here we have negative infinity. So a vertical asymptote of 1 over x is x equals 0. Okay, so let's find some more vertical asymptotes. Let's just find them for the function y equals 1 over x squared, and then describe the behavior to the left and right of each vertical asymptote. So let's take a look at the graph of 1 over x squared. Let's hide this one and look at 1 over x squared. All right, well, it's similar to 1 over x, except from the left, it looks like this function is also approaching a positive infinity on the y. So this function increases without bound, both from the left and from the right. So let's see. I would say that the limit as x goes to 0 from the left of 1 over x squared is infinity. And the limit as x goes to 0 from the right of 1 over x squared is infinity. So the vertical asymptote is x equals 0. So a quick note here, because the limit from the left and the limit from the right are the same, they're infinity, we can say that the two-sided limit, the limit as x approaches 0, no exponent of negative or positive of 1 over x squared is infinity. But we can't say that. We cannot say this for 1 over x because we had negative infinity to the left and positive infinity from the right. Okay, one more. Let's analyze the graph of f of x equals tangent of x. So back to Desmos. Let's close that one, open this one. Whoa, we got a lot of stuff going on here. There are a lot of vertical asymptotes of this graph of tangent of x. And it looks to me like, if we zoom in a little bit, that is happening at, let's see, so this would be pi. Yeah, so then this would be 0. And this would be another pi. So it looks like odd values of pi over 2 perhaps look like they are going to be the places where we have, in fact, let's check that out. Y equals pi, or x equals pi over 2. Yep, there's a vertical asymptote. What about at 3 pi over 2? Yep. What about at negative 1 pi over? Yeah. So there it is. Every time we have an odd value of pi over 2, we've got another vertical asymptote. And from the left, we're approaching infinity. And from the right, we're approaching negative infinity. So I would say then that the limit as x approaches maybe pi over 2 of the tangent of x from the left is, let's check that out one more time. So if we approach pi over 2 from the left, okay, we're at infinity. And as we approach pi over 2 from the right, we are at negative infinity. And I'm going to make a little note here. There and there, odd multiples of, let's say, all odd multiples of pi over 2. So, for instance, 1 pi over 2, 3 pi over 2, 5 pi over 2, and so on. And so all of those would be vertical asymptotes. So x equals pi over 2, 3 pi over 2, 5 pi over 2, and so on are all vertical asymptotes. All right, I'll see you back in the next video.